So now we're still in section 5.2, which is integrating with natural log forms, but I want to show you two special cases. So that's what both special cases will be in the same video. So my first special case is, what if your degree is higher on top? So if you look back and look at the ones that we did in the first video, you'll notice that we always had a higher power in the bottom. So usually it was an x squared in the bottom, and you would have an x on the top, or an x cubed in the bottom, you would have an x squared on top, which works out perfectly because if you let u be the bottom, you can get du to be some form of the top. If you have it flip-flopped, you actually have to do it algebraically first before you integrate. Algebra, again, is our #1 resource in calculus. And the algebraic technique is you actually need to do division. You can do long division or synthetic division. Synthetic division is easier, so I'm going to go that route. It's been a while, I'm sure, since you did synthetic division, so let me give you a little refresher. So you're going to take what's in the numerator and put the coefficients across the top of this synthetic little half box shape. Outside of it, you put the 0 of what you're dividing by. So you put -2. This is what allowed us to do basic division of polynomials. The first number drops down. Then you multiply diagonally and add vertically. Multiply diagonally, add vertically. This is your x. This is your constant. And this is your remainder. So what you actually have is x plus 4 with a remainder of 2 over the original divisor, x plus 2. So here's what that algebra step did. It took something that was not in a form that we could integrate because it had a bigger degree on top, and it broke it down into multiple terms, each we can integrate individually. So the integral of x is x to the second over 2, just a power rule. The integral of 4 is 4x. This last part, this is a du over u. If you let u be the x plus 2, derivative of that is just 1, or dx. No adjustment. Now the 2 that's on top, it does need to come out front. It's basically like an unneeded coefficient. And then you get the natural log of x plus 2. So it's a pretty easy way to use synthetic division. The reason we don't really talk about it until today is because you do end up with this natural log integral that we really weren't equipped to handle until now. So let me show you another one. So you put your coefficients across the top, put the 0 of what you're dividing by outside, drop down, multiply, add, multiply, add. So that means you have a 2x, a -3, and then a remainder of 5. These you do end up with a remainder. If you don't end up with a remainder, what that means is you actually could have factored and canceled something in the numerator with what's in the denominator. That doesn't happen often, but if it does, that's wonderful. Now we integrate term by term. So the integral of 2x is x squared. The integral of -3 is -3x. And then this last one is a 5 is the coefficient, and then the natural log of the u, which in this case is x plus 3. This is the piece that will be that natural log piece. So that's your first special type. It doesn't show up much. I mean, you could look at a ton of AP tests and really never see it happen, but occasionally you will have one like this that has that algebraic step to start with. The second special type, I actually think this is a little more common on the AP test, is what do you do if your integral actually has a natural log within it? Everything we've done to this point, it was a natural log was the result when you were done integrating. But what if it starts with 1 to start? Well, here's what I like about these. There's a lot of things in math that are not concrete rules. There's like always some exception to everything you learn in math, it feels like. There's no exception to this. If you see a natural log anywhere as part of your integral, it is always, always, always the u part. So when you go to do u substitution, you shouldn't even have to think about it. Your u has to be whatever that natural log piece is, no matter where it's located. So the derivative, well, the derivative of the natural log of x is just 1 over x, which is exactly what you have. So you'll look at, kind of use my highlighter here, this is that du piece. There's no adjustment that needs to be made. When you do these, though, you have to figure out what's being done to you. What's being done to that natural log of x that you called your u value? These are often power rules. This natural log is being cubed. So this is just a u cubed du. Integral of u cubed is u to the 4th over 4, which is the natural log of x to the 4th over 4 plus c. So these have a natural log in it, but they actually are more similar to what we would have done earlier in chapter 4 because there's a lot of power rules. So I want to look at these two side by side because they're very similar in kind of their look. Both of them have just a natural log, but the location of that natural log is different each one. So for both of them, your u is natural log of x, has to be. The derivative is 1 over x, which they both have. They both have this 1 over x here and this 1 over x here. So neither of them need an adjustment. But they're slightly different form. This, I'm going to start with number 2, just go in order. This one, your u is on the bottom. This is actually a du over u. Because your du, or your u, which is natural log of x, happens to be in the bottom to the first power. So it is a du over u, which means you get the natural log of the natural log of x. It is an embedded natural log. We actually learned how to derive that in the previous lesson. The second one, or technically on this slide, it's the third one. This one, your u is on the top. And it's just to the first power. So you can think of it as u to the first. This one's actually more like this one. It is a basic power rule. So your integration would be u to the second over 2. This one I feel like it's almost so simple, it's hard. So you get the natural log of x squared over 2 plus c. The only situation where we get this embedded look, this natural log of natural log, is this one. All of the other ones are power rules. So it could be any power. I think I did one on the homework that was a 1/2 power or a 1/3 power, or it could be a negative power. You're really, really looking for power rules with these, other than this one middle piece that shows you kind of the most off the wall technique that we can do with integrating natural logs.